Now I know.
So, by way of introduction, our goal is, as we did the last previous days, we're going to take the translation of data this time and see how it applies to what we talked about earlier, the translation of graphs. And here's the key, is that we want to see the effects on what's called the measures of center. Things like mean, median, and mode, that kind of stuff. Okay? So, our first thing we had to do is find the mean/average of the following data sets. Some of you noticed those are consecutive numbers, but that's not important. Some of you noticed that these are consecutive numbers, which is important. Wait, it's not important that those are consecutive, but it is important that those are consecutive. And we'll see why in a second. So this one here is 105.5 FM, pure rock radio. Next is the next data. What did you get for that one, please? And so the question on C is not how to find a shortcut from here to here and from here to here, but how to find a shortcut from here to here. So as we look here, 30 plus 35 plus 35 plus 35, and since that pattern goes the entire, for every single element, plus 35. So the average of the second is equal to the average of the first plus 35. Which, these elements right here, is the same pattern. If you add 35 to all your data, then this also shifts 35. And that is going to be the crux of what we're going to talk about today. And not only mean, but others as well.
No, I'm just kidding.
So what we're going to do today is look at data being translated. Data being translated. So here's one application, whether you like golf or not, at least we can begin to understand a little bit. So this is actually data from most recently, just a couple days ago, the PGA Hero World Challenge. And look at this guy from Japan, Matsuyama. He won $1 million.
I didn't even know they played golf in Japan.
Good. Apparently they play baseball too. So
I know baseball.
Okay,
baseball.
now
Golf.
here's the key. Shh. Here's the key that I want you to see. He scored 270, and if you remember how golf works, it's the lowest score that wins. But here's an alternate way that they talked about the data. So, on a particular hole, let's just say, and it doesn't always correspond, but generally speaking, to get to the general score for a hole should be three strokes.
What?
To shoot, woo, boom, and then one more, and then one more. That's called a par 3. Okay? So most holes in golf are a par 3. In other words, they expect you to make the shot in 3 swings. Okay? So when you make a birdie, which is you do it in 2, or a hole in one, of course, that's a 1. So birdie is 1 under, and a hole in one is 2 under. Okay? So what you do here is just take, for round 1, par was 72. And in fact, 72 is all the way across the board. In other words, it should take you 72 swings to make to finish the round. Okay? But notice what this guy has consistently done. He has consistently gone under par. So instead of saying the score is 270, we say he's 18 better than we expected. This guy, 16 under, 13 under, okay, et cetera, et cetera. And even way down here at the bottom 20, and notice that they still earn money right there. He's above par by 1, just by 1, and he still made $105,000 for swinging. Okay.
Yeah, we're not going anywhere.
So he is 17th place right there, and he was 1 above par. So you can talk about the data as a raw score, or you can shift all the data over and talk about it relative to par. So the lowest score here or the lowest score here is still going to give you the same thing. Okay, so that's the idea of shifting data, why we want to shift the data, and what things are going to change. So first off, let's answer some questions down here. Take a moment. What does the word par mean in a golf match. Is it match? Is that right? You don't say golf game. You say golf match. Okay, just got to make it. Next, what does 2 par mean in the column? And so what transformation is happening? So take a few moments with your neighbor and chat about that. All right, so of course, par means the expected amount of swings. The expected amount of swings. And of course, generally, it's going to be 3 per hole. Three per hole. If it was a very easy hole, it might be a 2, par 2, or if it were a very difficult hole, part 3. All right, so what does 2 par mean? It means how does their score compare? How does the score compare to par? In other words, are we above the expected, below the expected, or at the expected? And lastly, what's the transformation? This is a translation. And the translation of data is just going down. Now, there is no X and Y here, right? It's just one data. So if I were to say it, I would say X. Well, actually, let me write it out a little bit better. The translation of data of X, because we're only dealing with X, it translates to X minus 200. 288 there. On page 2, your job is you're going to enter this data, all the data, into L1 on your lovely calculator. And your job is to walk through these steps to see what happens when we do shift data. Okay? So by way of introduction, I'll read it and then let you get at it. The 19th Amendment was passed in 1920 in the United States, giving women the right to vote. This activity will compare the year in which other countries passed a similar law relative to the United States. So here we are, right here, 1920, among one of the first countries, as you can see. And so these guys were slightly before us, and all these after. And, of course, there's more data. Hopefully, there's more data after 2005. So please go ahead and start. Notice we're only taking the numbers in L1. You don't have to do anything with the words. So go ahead and start entering and follow the activity. Go. So when we make our histogram here, bin size, the place that we can change the bin size is in window. And from there, we do the X scale, and we set that equal to 10. When we do that, we get these two graphs, and we notice exactly that the graphs are exactly the same. Just here's my axis right there. And this one, the axis is way, way, way down. All right, so that's what we notice here is that the actual graphs are exactly the same. Now let's analyze and use our calculator to find these. Now, of course, range, mode, and IQR, you kind of have to eyeball it. Well, with range, we calculate using the max and min. The IQR, we calculate using the Q3 minus Q1. And the mode, we just eyeball, okay? So my average is going to be 1947, and I'm going to go ahead and put the 0.02, although the average is about 1947. Next, my standard deviation, which you can see with the capital S. So recall that your standard deviation on the calculator is capital S, and they say little SX. And your standard deviation, as you can see there, is 29.16. So the max of the data is 2005, and you're going to subtract the 1893 to get the range of that. So the range here is 112. All right, so there are two modes because there are two most of them. So 1918 is one of them, and the other one is 1947. Is that median is right there, 1947 we see. My calculator and the IQR. Remember that IQR is Q3 minus Q1, so we have to do the subtraction manually, which is going to be 1969 minus 1918.5. And we get 50.5 there. So after we go to stat calc and change it to L2, my mean here is 27.02. My median is 27. My mode and median, I'll get to that in a second. My range, of course, is the max minus the min, and the max is 85, and the min is negative 27. So my range is 112. My IQR, in this case, is going to be 49 minus a negative 1.5, which will give me 50.5. And I'll fill it up. I'll let you see that in a second. Standard deviation, we can see from the S there, is 29.16. And when I look at L2 and just scroll through, I see that I have 4 negative 2s, 4 27s. All right. Now, what do we notice about the data? Well, if I adjusted, remember that the adjusted is just the original minus 1920, the United States. So if I subtract 1920 here, subtract 1920 here, subtract 1920 here, I get the exact numbers. But notice what doesn't change. Range is the same. IQR is the same. Standard deviation is the same. So from this example, this isn't a proof, this is just an example, we can come up with 2 theorems about centers of data and spread of data and how they are affected when we translate the data. All right, so let's see here. Which numbers in the 5-number summary are affected by translating the data? Mean is changed. Median is changed, as is the mode. So which ones are unaffected? In this case, my range, my IQR, which is a range, just not max and min. And lastly, my standard deviation does not change. So that's going to yield us 2 theorems, which we'll introduce in the next pages. Introduce this next theorem and prove it, because this is pure math, is proving. Yes. You are not responsible for the proof, yet it's so beautiful. So I don't want to say, but you don't have to touch it. No, it's just beautiful. All right, so here. Adding h to each number in a data set. And remember, adding is the same thing as subtracting, right? If you add a negative. To each, what it does is if you add h to all the data, then it is the same as adding h to the mean, to the median, and to the mode. So in other words, the centers of data also get translated. The centers of data also get translated. All right, so we're going to start off with a data set. And notice the data set has just a collection of numbers. It is not necessarily in order. It doesn't matter what the data set is. It's just a bunch of them, and it ends at n. So we have n number of elements. So there's my data set, and we're going to translate it such that whatever the data set is, or excuse me, the element, we just add h to it. Remember, adding h can also add a negative. So we could be bringing it down like we did in the 1920 example. Okay, so what's that mean? The mean of the data, of the new data, is going to be this. So here is what our mean is. Let's unpack it so we don't panic. This just says each element added h to it, okay? So this is the element 1 of the new data. Then we add element 2, add element 3, and we stop adding until we get to here. So the top just says add up all the elements, the sum of the elements. Divide by the number of elements. So that's, of course, your average or mean. What does average mean? It means we add up all the parts. So this is going to take a moment because we're going to expand. We're going to expand this out. So I'm going to say x1 plus h plus x2 plus h plus dot, 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 plus. In the end, we get xn plus h, okay? And how many of these are there? There are n terms, or n elements there. And of course, we're dividing by n. That's what average means. That's what the mean means. We just add each element all the way up until we get to the last one, and then we divide by the total number. Okay, now of course, if you recall the commutative property and the associative property, since everything here is adding, I'm going to move things around such that I just have all my x pieces together. And let me clean that up real quick. Plus x sub n plus h plus h plus h. And remember, in this case, I have n of these and I have n of these. And all of this is still being divided by n. So all I've done, see the h's right here? I'm not undistributing it. It's not factoring out, folks. I'm just moving them around. In other words, combining like terms, right? These are my like terms. I combine my like terms. So what does this part mean right here? Folks, this is the original average.
Wait, what's that under? What's a 12?
Sorry, that's an n. All right, so if I equals 1 and we go to n, and this time I'm just adding up the original, just the I, xi, divided by n, plus nh divided by n. Again, let's unpack where that came from. There are nh's here, so that's n times h, and the n down here is on the bottom.
We're not going to have to memorize.
What do we notice here is happening?
Cancel it then.
The n's can drop out. So in the end, what we say is this.
It's the mean.
The average or the mean of the original data plus h. So this brings us to our next theorem, which we're going to prove one of them, and this one is micro-mini. All right, so adding h to each number in a data set, just like we did before, does not change the range or the interquartile range, the variance or standard deviation of the data. So we're just going to look at one of these proofs and consider that. So under the translation of h units, the minimum m is mapped to m plus h, right? Because all we do is if the original minimum was 14 and then we add 10 to it, our new data is here. This is just an example. So the max is also shifted up as well. So if we recall, the original range was this. The original range was capital M, the max, minus the min, okay? Now here's the new range. Here's the new range. The new range is just capital M plus H minus small m plus h. But what do we do there with that negative? It's going to distribute that negative across here. And what happened to our h's? Our h's drop out. And so in the end, the range remains the same. All right, so that one was much more less complicated. Learn to speak. A similar proof can be derived for the other spreads. Capital S, since the measures of spread do not vary under translation, they are called invariant. Invariant. I'm not going to use that term very much, but I just wanted to give you that there. So let's walk through an example here. All right, at a martial arts tournament, the 20 fighters weighed in before the tournament. All the fighters made weight, and a statistician computed the following statistics. All the way across the board. Mean, standard deviation, median, and IQR. However, after finishing her calculations, it was brought to the statistician's attention that the scales were not calibrated. The starting weight was set to 0.25 pounds, not to 0. So find the correct values of the above fighters. So let's start making a list here. Standard deviation is going to stay the same. according to that theorem. We know that the mean will change, and it's going to go up, or is it going to go down? So since the data was originally at above, the original data was this, we have to shift it by subtracting 0.25. So that means the median now is going to be 194.25 pounds. Well, so we have the mean will also go down, 191 pounds. And lastly, the IQR is going to stay the same. There we go.